Hello guys, this is Prime Concept once again. Now we have a problem to analyze under the thin lenses. And this problem is a problem under what we explained in our previous video. So do well to check the previous video so that you would understand, right? Now we said two thin lenses are in contact. So this is a problem under combination of lenses. That is to say finding combined focal length. Two thin lenses are in contact. An object placed at a distance of this. So the object distance U is 45 cm. So we already agreed that our object distance should always be what? Negative, irrespective of concave or convex lens. For both of them, your object distance should always be what? Negative from the lenses forms a real image. So the image they've told us is real. And if our image is real, it simply means that the image distance will be positive. Forms a real image at the distance of 30 cm. So V is going to be 30 cm positive, right, for real images. Now, the lenses, okay, from the lenses, one of the lenses is converging. One of them is converging, that is to say, a convex lens with focal length 15. So this is f1 and the focal length is 15 cm. Will it be positive or it's going to be negative? Of course, since it is converging, it means it's going to be positive. So they said determine the focal length, determine the nature and focal length of the second lens. So we want to find f2. Remember, what we are dealing with is that they told us that they combined two lenses to become one. They combined two, and those two are now acting as one lens. So since the two is acting as one lens, this is the object distance from that two that is acting as one. This is the image distance from that two combination that is acting as one, right? So it means that the two lenses acting as one should have a combined focal length, right? So which I'm going to call just f. So f is now the focal length of the combined lenses, which we can get from the object distance and image distance. So once we get the combined focal length, we can then find the focal length of the second lens that is in the combination. So solving this using our normal lens formula, you would notice that from our lens formula that 1 by f is equal to 1 by v minus 1 by u. So 1 by f is going to give me 1 by 30, which is v, minus 1 by u, and u is minus 45, right? So I have 1 by f equals 1 by 30, then minus times minus will now become plus 1 by 45. So 1 by f equals my LCM. I'm going to take 90. So that 30 in 90 is going to give me 3. 3 times this is 3. 45 in 90 is going to give me 2. 2 times this is 2, which is going to give me 5 divided by 90. So that my f combined focal length becomes 90 divided by 5. So if I solve this, I should have 90 by 5. I should have 18. So this is going to give me 18 cm. So this I have gotten is not what I'm looking for. This is just the combined focal length. But I'm looking for focal length f2 of one of the lenses in the combination, right? Now, and they also say we should determine the nature of f2. When they say nature, they want to know if f2 is going to be a converging lens or diverging lens. We already know that f1 is a converging lens or a convex lens, but we don't know whether f2 in that combination is also convergent or divergent. So you recall I gave a formula for finding combination, right? So we have that 1 by f, which is the formula, is equal to 1 by f1 plus 1 by f2. So I'm looking for this. Now we already know that f1 is positive because it's a convex length. So I have this 1 by what? 18 equals 1 by 15 plus 1 by f2. So I don't have to attach any sign to F2 because I don't know whether F2 is converging or diverging. So I'll just solve that way. So to make F2, I have 1 by F2 equals 1 by 18 minus 1 by 15. So 1 by F2 is going to give me my LCM here. What can I use now? I think I can still use, okay. 18 by 15. So 60. Okay, let's just multiply this so that we don't waste time. Let's say 18 by 15 to be easier for us. So let's just say 270, right? I just multiply this to have 270. So that 18 in 270 is 15. So I have 15 minus 15 in 270 is 18. So I have this. Right? So I have 1 by F2 is going to be 15 minus this, which is minus 3 by 270. And then my F2 is simply going to be, my F2 is going to be the inverse, which is minus 270 divided by 3. And this would give us minus 90 cm. Now you would notice that we have gotten our answer, right? And then what is the nature? Since we got a negative sign, it simply means that we're dealing with a concave lens, also known as diverging lens. So the nature of the second lens is that it is a diverging lens, or you can say it's a concave lens. What about the combination? Of course, they didn't ask, but then if you are to answer, this is the combination, which is positive. So since your combination is positive, it means that your combination is now going to represent a converging lens. I believe this concept is clear to you. Please, if you have enjoyed this video and you are yet to subscribe, please do well to hit the subscribe button, like this video, comment and share with 10 of your friends. Tell them this is Prime Concept. Thanks for watching.